We now move to the second planet of the gas solar system, the gameplay effects. So by game design, what exactly are gameplay effects? Gameplay effects are a certain set of operations that we can perform on an actor. These operations include modifying attributes, granting a tag or a label to an actor, triggering visual and audio effects, and so on. Sometimes it can be any one of the mentioned operations, and other times, all of them. In this topic, we will learn 5 different effect types: the instant effect, the periodic effects, which can be further classified into duration periodic and infinite periodic, and the non-periodic effects, which can be further classified into non-periodic duration and non-periodic infinite. In my level, I've got 6 actors. The 3 actors to my right are actors that damage me, and the 3 actors to my left are actors that heal me. Now let me run the console command show debug ability system, and in the debug information, you will notice that I have 0 health, mana, and stamina. If I consume this green orb, you will notice that I have instant healing to my health, mana, and stamina. This actor is a sword actor, and every time I walk into that sword actor, I will take 20 damage to my health. This actor is the fire area actor, and if I walk into it, I will be taking periodic damage to my health. You will also notice that I had been granted certain labels, like element.fire, damage.periodic, and so on. Whereas consuming this actor will give me a periodic healing, and it will also label my ASC actor with element.water label. This actor is the electric sparks actor. It will apply the same fire effect, but running multiple times into it can stack over each other and increase in their magnitude. And finally, this actor is a healing fountain actor that applies an infinite periodic effect that heals my health, mana, and stamina. You will notice that the label heal.fountain still exists on my actor, meaning I'm still under that effect. So even if I take damage from the sword, or I'm under the fire effect, I'm still being healed. So in this topic, each actor in the level will cover different effect properties. We will also be implementing the non-periodic duration and the non-periodic infinite effects. So let's get started. In the first section, we'll be applying gameplay effects. Beyond the assets, pawn, and src folder, I have created a matter folder, within which I will have all of the actors that constitute matter in my game, like maybe even a rock, or an arrow, or a sword, or even an area of effect. So I have a volume of effect folder, within which I have created my 6 volume of effect actors. Let me first start with this Tango actor. I've tried to depict it similar to the Dota 2's Tango item. This Tango actor is nothing but a sphere static mesh, and it has the material ground grass from the starter content. So I've tried to depict it similar to that grass or leaf theme as in Dota 2. I've configured this static mesh component to generate overlap events, and I have implemented the onComponentBegin overlap event. So within this onComponentBegin overlap event, now from this other actor, which is actually the overlapping actor, I will use the Ability System Blueprint library's getAbilitySystemComponent method. This method is actually part of the Ability System Blueprint library, which is actually a collection of functions, commonly known in programming as function library. These function libraries are nothing but classes that contain a collection of functions, and this method is accessible anywhere. It simply takes in a parameter, an actor object pointer, and it attempts to call its Ability System Interface method, that is a getAbilitySystem component that we implemented in C++. So I will pass the overlapping actor into the actor object pointer parameter, and I will validate for this returning Ability System Component object pointer. Now let me see if this ASC is even being accessed. So in my level, if I run into this Tango actor, you will notice that it has printed the base player state and Ability System Component, which is exactly what we had configured for our hero character, where the ASC exists on the player state. So this works. And now we can apply any effect to this Ability System Component. Now before I proceed any further, I want to offer you a task. Go ahead and make the other effect actors in the same volume of effect folder, such as the weapon hit, the bottle, and the 3 volume of effect actors. The weapon actor contains a static mesh at its root scene component. This static mesh is nothing but the static mesh sword that I got from one of the Unreal Engine Marketplace's assets called Weapon Pack. You may use any sword static mesh, and as its child scene component, it contains a capsule collision volume. The dimensions of this capsule collision has been set accordingly. So this pretty much constitutes a weapon. Generate the overlap events for this weapon static mesh and implement its onComponentBegin overlap event so that you can operate on the overlapping actor of this weapon static mesh. The bottle effect actor is also nothing but a sphere static mesh. It uses a particular disk material that's part of the VR editor that comes with this project. I didn't create any material in this topic. This burn area actor has a plane static mesh, a box collision volume, and a particle system. For the particle system, I use a p-fire that's part of the starter content. The box dimensions set accordingly to the plane, and the plane is nothing but the plane static mesh. This box collision volume has been made to generate overlap events, and I have implemented the onComponentBegin overlap event. In the similar manner, I have created this healing fountain actor, which has a plane static mesh, a box collision volume, and the particle system. Again, the particle system is called Steam Lit, which is part of the Unreal Engine starter content. Generate the overlap events for this box collision volume and implement the onComponentBegin overlap event. So it's really very simple. Create all of these actors. So now it's time to apply the Tango gameplay effect. As you may already know, gameplay effects have to operate on an actor. They can modify attributes, they can grant a tag or a label to an affected actor, and trigger certain audio and visual effects. Gameplay effects in GAS can be configured using blueprint classes. So in my content directory's base folder, beyond the assets, matter, pawn, and src folders, I have created an ability system folder. This is where I will store all of the classes relevant to the ability system. I have created an effects folder within which I have stored all of those gameplay effect classes that I was talking about. Right-click on an empty space and click on Blueprint Class option. Search for the gameplay effect class and click on Select. Name this gameplay effect Tango, or rather GE Tango, that is a gameplay effect Tango. So this is what a blueprint class of a gameplay effect looks like. You may close every other panel like the event graph and my blueprints because this blueprint class does not implement any function. So yes, this class is a data-only class. This is where you will specify all of your effect-related data. You can configure the duration of this gameplay effect. So I had mentioned the 5 different effect types, right? The instant, duration, and infinite, and duration and infinite having periodic and non-periodic effects. So as a practice, you should first specify the duration policy, and I shall only use instant. This modifiers property is what is used to modify attributes. It is nothing but an array where each element contains the attribute modifying operation. In the attribute property of this array element, you can choose any one of your specified attributes. Notice how attributes are written in this manner. The attribute set class name, a dot, and the attribute name. So such an attribute property in blueprints contains all of your declared attributes across every attribute set class. I will now choose the base attribute health. In the modifier operator, I can choose among the several operations add, multiply, divide, override, and invalid. So let me choose add. So after having selected the attribute to modify and what operation to perform on that attribute, it's now time to set the modifying magnitude. This modifier magnitude category has the property magnitude calculation type. You can choose one of 4 different calculation types. That is a scalable float, which will allow us to simply hardcode a scalable float magnitude. Attribute based, that will take the magnitude of another attribute, like increasing your health based on a health region value. A custom calculation class, which is quite advanced, and you will learn at a later time in this tutorial series. And finally, the set by caller. I will now use the scalable float magnitude calculation type. I shall just use a value of 50. And now, this modifier element states that I should add 50 to my health attribute. Similarly, you can add another modifier element. You can choose the attribute base attribute set.mana. I will add a scalable float magnitude of 600. Similarly, you can specify as many modifiers as you'd like. I will use the next attribute stamina, and I shall add a negative value of 60. Let me compile this class. So whenever you want to deal damage, you still have to use the add operation, but use a negative magnitude. So this technically adds minus 60 to my stamina. I have deliberately set such values like 600 and minus 60, and let's see how it works. So this effect's configuration states that it is an instant effect, which modifies the health, mana, and stamina. So back in your Tango actor, from the ASC object pointer, filter for apply effect. You will notice that there are 4 methods. Let me first show you the apply gameplay effect to target method. This method is called from this ASC object, but it also requires a target ASC object. Technically, it operates on source and target ASCs. That is, this method calling ASC is a source ASC, like maybe an instigator of an attack, and the damaging actor will be the target ASC. But since we don't have a source and a target in this context, we will delete that and simply call the apply gameplay effect to self, which does not require a target ASC. The second parameter is the gameplay effect class. We will use the gameplay effect Tango, and optionally, you can also pass the level of that effect, like maybe in Dota, where certain ability effects get enhanced as the ability levels increase. So those level numbers can be used to influence your magnitude values. You can pass in a curve table which has the magnitudes for different levels, and we will be implementing this in a future topic. So that's all there is to apply the gameplay effect to this overlapping actor. Now when I play my level, when I see the debug information of this actor, if I attempt to consume this Tango actor, you'll notice that my health has been set to 50, but my mana didn't go all the way up to 600, it remained at 300. Whereas the stamina didn't go to the negatives, it remained at 0. So despite setting correct values, why did only our health get an addition of 50, but our stamina didn't get the full addition of 600, and our stamina did not see any subtraction down to minus 60? So why did that happen? Well, this was because of the pre-attribute change method, where we clamped the new values of health, stamina, and mana. This clamping was done between 0 and the maximum health or maximum mana or the maximum stamina, which has been initialized in the constructor at 300 value each. So technically, just before that attribute value changes, this pre-attribute change method is executed, as we had learned in the previous topic. This new value is what will be the attribute's new value, and this new value has been updated by validating for the health, stamina, and mana attributes. So now, this ensures that our health, stamina, and mana attribute values will never exceed those bounds. And which is why, if you have to apply an effect when the game begins, you can confidently override any attribute's value to a really high value, and that will be clamped within those bounds. So this completes the application of the Tango effect, and you can call the destroy actor method to destroy this Tango actor when it has been overlapped and picked. Similarly, in my sword actor, in the weapon mesh begin overlap event, I have validated for the overlapping actor's ASC and applied the gameplay effect to self. Although if it's an equipped sword in a game, the source actor will be the owner of the sword, and the target ASC will be the overlapping actor's ASC, and then you can use the apply gameplay effect to target. This gameplay effect weapon hit exists in my ability systems effects folder, which is also an instant effect that modifies only the health. It adds a value of minus 20, that is, it subtracts 20 from the health, which is nothing but 20 damage. Now this is an important thing. Effects are always applied on the server. GAS does not execute effects in the client. We will face this issue later on when only the client knows the effect target and not the server. In the second section, we will be implementing periodic and non-periodic effects. Periodic effects can be of two types, duration and infinite. You can think of a duration periodic effect to be something like the flame effect. In most games, this flame effect damages an actor periodically, and this happens over a certain duration. As for the infinite periodic effect, you can think of it to be something like a health regen effect. So this can be permanently granted to any actor, such as the health, mana, and stamina regeneration in Dota 2. In the volume of effects folder, let's work on this bottle effect actor. So this actor is nothing but a sphere static mesh that uses a simple disk material that comes with Unreal Engine Editor. In its onComponentBegin overlap event, I'm validating the overlapping actor's ASC and applying the gameplay effect to self. This is nothing but the gameplay effect attributes heal duration in my ability system and effects folder. As I had stated, the first thing you want to do is to specify the duration policy, and this duration policy has been set to has duration, and this reveals a duration magnitude category. This is where you can specify the magnitude of the duration, that is how long this effect will last for in seconds. As with the modifier magnitude, this duration magnitude also has the magnitude calculation type property. You can choose from among the 4 calculation types, and for this example I shall use a scalable float and specify the scalable float magnitude of 5 seconds. Now before I show you the modifiers, let me talk about the periodic tick. The periodic tick is the interval within which the effect executes. These 2 properties of the period category is only revealed in the infinite or has duration policy. Now you can specify in seconds what should be the periodic intervals. So in the period property, I've specified 1, which means this effect will keep modifying that attribute every 1 second. Think about this to be like the damage per second or heal per second. This effect executes every 1 second interval. This property, execute periodic effect on application, means if it is true, the effect will apply immediately upon its application, whereas if it is false, the effect will only execute after its first periodic interval. Think about it to be like the silencer's ability in Dota 2, where he applies an effect that lingers on a character for a certain duration and then causes damage. So that does not execute on application. Now let's see what are the modifiers I'm operating on. Firstly, it's my health, where I'm adding a value of 10. So technically, this magnitude of 10 will be added to my health each periodic interval. The second modifier is on the mana attribute, where I'm adding a value of 20 every 1 second. And the third modifier operates on stamina, where I'm adding a value of 30 every 1 second. You can also choose to multiply, and this would multiply a value of 30, so you can do that as per your game design. So it's just as simple as that. A duration periodic effect is where you specify the duration policy to be has duration, set a magnitude for the period, and if the execution should happen on application, and specify the attributes to modify. And that's how in my level, if I consume the bottle actor, you will notice that in the first 1 second, I did not have any effect execution, meaning the execution happened only after a 1 second periodic interval. So a 10 health per second has resulted in a 50 value, a 20 mana per second has resulted in 100 value, and 30 stamina per second has resulted in 150 stamina value. Now let's move on to the burn area actor, and I have implemented this area's box collision volumes on component begin overlap, where I will validate for the ability system component and apply gameplay effect to self and pass the gameplay effect burn damage. This effect is also in the ability system and effects folder, where for a duration of 6 seconds and for a periodic tick of 0.5 seconds executing on application, it will subtract a magnitude of 5 from health. That means per second, it is actually going to subtract -10. Note that this is not -5 DPS, rather it is -5 per period. This periodic interval being half of a second means I will deal double the damage in that 1 second. So yes, that's a problem in the effect classes. You do need to be careful while specifying your DPS magnitudes. Now beyond these modifier operations, period, and duration, I want to talk about stacking. There is a stacking category under which there are stacking properties. You have the stacking type, which is either aggregated by source or by target. So source means we are counting by the stack of the source's application. So yes, there is a stack even on the caster, and we will be counting by that stack number. So let's set this to aggregate by source and set a stack count limit of 3. So this means this effect can stack up to a maximum of 3 times. So a 4th application of this effect will not happen. So what do we actually mean by these stacks? Well, these stacks actually multiply on the modifier magnitudes, kind of like a coefficient on the magnitude modifiers. So we can technically limit those stacks. So with stacking, this effect operates as a singular effect, whereas the non-stacking type means multiple applications of this gameplay effect are treated as separate instances. That is, you will have different instances of these effects, each operating independently. So in this case, there is no tracking of the stack count, so you should be really careful while setting the stacking of such periodic effects. You can choose to have the duration of this effect refreshed if you get another stack, kind of how another Jingu stack gain will reset the duration of those Jingu stacks. You can also choose to refresh the stack's periodic execution. And in the stack expiration policy, you can specify if you want to clear the entire stack after the expiration of this duration effect, remove a single stack and refresh the duration. So now it'll operate on one less stack count, or should it just simply refresh the duration without decrementing the stack count? So this is kind of like making this effect infinite, and you may have to use another callback like onStackCountChange and manually operate on those stack decrements. So let's see the stacking in action. In my level, first let me consume the Tango actor and then run into the burn area effect. So you can see that I'm taking the periodic damage every 0.5 seconds, which is twice as fast than a 1 second periodic interval. Now let me replenish my health, and if I run into this fire actor multiple times, you will notice how the damage taken to my health is first 5, and then 10, and then 15. So the fourth effect application does not happen because we have limited the stack count to 3 by the source. Now let's see what happens with none. In my level, after consuming the Tango and the bottle, if I run once, twice and thrice, maybe even 4 times, you will notice that I was taking damage at irregular intervals. They did not happen in periodic intervals of 0.5 seconds, and this is because each of these effects are executing independently. They have not really been stacked, and consequently, the modifier magnitudes have not been multiplied. So this can be problematic in your game, so you should be really careful while specifying the stacking type. Now let's explore the infinite periodic effects, such as your base attributes regeneration. This is done in my healing fountain actor, where I'm working on the box components on overlap event. So I'm applying the gameplay effect to self, that is the gameplay effects, that is the attributes heal infinite. Now this effect is really very interesting. This effect has been set to be infinite in its duration policy, and it happens in every 0.2 seconds of a periodic interval. Now in Dota, some percentage of strength can be used as health regeneration, and that is exactly what I've done in this gameplay effects magnitude modifier. I have added to the health attribute a magnitude that's calculated not with a scalable float, but attribute based. So this attribute based magnitude calculation type exposes the attribute based magnitude category, and within this category you have several properties. So first you want to specify the backing attribute. So in the attribute to capture property, I've specified the core attribute set's strength attribute. The best part is, this attribute can be either the source or the target's. Think about the target attribute source to be like the OD's Arcane Orb ability that does more damage based on its intelligence. We will understand what is snapshotting later in a future topic. You can also specify an attribute curve table that will multiply onto this attribute's magnitude, and you can choose the attribute calculation type if it is the current value of the attribute, its base value, or its bonus value, the current value minus the base value. And finally, you can add the pre or the post additive values and its coefficient. So it's quite self-explanatory, where this is the magnitude before the coefficient is applied, and this is the additive after the coefficient's application. So if the coefficient, pre and post additives are C, A, and B for the attribute magnitude M, this follows the formula M plus A the whole times C plus B. I've done the same for mana, where I'm adding the 0.2 or the 20% of the source AC actor's intelligence, and similarly for stamina, where I'm adding 30% of the source AC actor's agility, calculated by its current value. I've also made sure it's a single stacking effect aggregated by the source, so there can't be a double or more fountain effect for any AC actor. So if you really play around with this, you can actually understand a lot of these gameplay effects properties So in my level, when I run into that healing fountain actor, notice how rapidly my health, mana and stamina are increasing. This is happening every 0.2 seconds interval. And obviously, they all clamp at 300. So no matter which effect has been applied to me, this healing fountain effect will remain on me infinitely. Now let's see non-periodic effects. A non-periodic and a duration effect would be something like a movement speed gain, where your character gains an additional movement speed for a certain duration, and that will be reset, like Dota 2's Haste Rune or the Phase Boots item. And an infinite non-periodic effect could be something like a bonus armor, where permanently a hero can put on an armor, and this armor boosts certain stats, like increased health regen, more damage reduction, and so much more. So first let's work on the movement speed effect. Let me duplicate my Tango actor, and let me call it something like rock. And for this rock actor, I will just change the material to something like ground and gravel, which is again part of the Unreal Engine starter content. Now for the overlap event of the sphere component, I will apply a new movement speed effect. So let's go to the ability system and effects folder, create a new gameplay effect class, and call it movement speed, and prepend it with G and E. So this is the gameplay effect movement speed. I will first set the duration policy to has duration. I will set the duration magnitude calculated by scalable float to about 6 seconds. I will add a single modifier, and I will search for the movement speed attribute, part of the battle attribute set. I'll use the override operation, and I will override to a scalable float magnitude of 2000. After specifying the duration and the modifier, since it's a non-periodic effect, I will keep the period to 0. I will now compile this class. So this means without any periodic tick, this override effect will remain for 6 seconds. So back in the hero class, let me use the newly created gameplay effect movement speed, and I will compile this class. Now it's time to place this rock into my level. So let me just drag it there and zoom in a little bit and adjust its position. And now when I play my level, and if I inspect the debug information, you will notice my movement speed to be about 100. And if I walk into that rock actor, you will notice my movement speed to be about 2000, the base value being 100. You can also see what effect it is under, that is a gameplay effect movement speed, and after 6 seconds it reverts back to 100. So in this manner, a duration non-periodic effect can actually reverse an instant effect. So after the duration expires, that attribute reverts back to its base value, as we learned in the previous topic. Similarly, let's create an armor bonus. So in my effects folder, I will create a new gameplay effect class called gameplay effect armor bonus. I will first set the duration policy to infinite. So this effect is permanent unless manually removed. Notice that I don't have to set any duration magnitude for this, and the periodic tick will still remain 0. I will only add a single modifier that modifies the armor attribute from the battle attribute set. I shall add a value of 30, or rather 300, and let me compile this class. Now in the same rock actor, I shall choose the gameplay effect armor bonus and compile this class. Now when I play my level, let me inspect the debug information. You'll notice his armor is 0. So if I consume this rock actor, you will notice my armor has been clamped to 100. It has an additive of 300 under the gameplay effect armor bonus, but it has not been added from 0 to 300. Because in our battle attribute set class, we had configured our armor to be a percentage between 0 and 100. And this was clamped in the pre-attribute change method of the battle attribute set, where the new value of the attribute armor has been clamped between 0 and the max armor, and the max armor initialized to 100. So now we need to manually remove this armor effect, and then the armor value will return to its base value. Now in my pawn folder's blueprint hero class, let me implement an event for a button press. So I will search for debug key F, and when the F key is pressed, this event will be invoked. First I'll get the ability system component of this blueprint hero by using the Ability System Blueprint Libraries method, passing the self reference, validating for this ASC object, and we will call its remove active gameplay effect by source effect. This method will remove any active gameplay effect for the specified gameplay effect class. And just like applying gameplay effects, this function will only execute on the server. So let me specify the gameplay effect armor bonus, connect this execution pin and arrange this node. Notice that you also have an optional instigator ability system component parameter. There is also a stacks to remove parameter, which will remove the specified number of stacks, and a negative value will remove all stacks. Now let me compile this class and play my level. Inspecting the debug information, when I consume this rock actor, you will notice that I have a permanent armor of 100, and if I press the F key, you'll see that the armor reverts back to its base value. So this is how you can remove a gameplay effect. You have many other methods to do the removal of the gameplay effect, such as remove effects by tags and remove active gameplay effect, which requires something known as gameplay effect handle. So in this section, we have covered all of the 5 effect types.